to you in the problem. So like I mentioned, if there's no picture given, make sure when we get to these problems, always draw a picture. And label it. Pictures will be your friend. All right, so always draw a picture and label it if it's not given to you when we're setting up these problems. We're talking about buildings, ladies and gentlemen, and to the ground. Hopefully, unless we're at the Leaning Tower of Pisa, all of our buildings are perpendicular to the ground. We certainly do not want to be in a building that is not perpendicular to the ground. So we can assume that any time you're given a diagram where a scenario where you're talking about a building, your building is going to be perpendicular to the ground. So for example, the hypotenuse of a right triangle is 3 feet. If one leg is 1 foot, find the degree measure of each angle. So again, I'm going to draw my picture. Again, it's a right triangle. So I'll label my one side my right triangle. Just to refresh my memory, the hypotenuse is always across from which angle? It's always across from the what? The right 90-degree angle or the right angle, exactly. So they're telling me my hypotenuse is 3 feet. They're telling me that one leg is 1 foot. So again, it doesn't matter which side I label as 1 foot. So they want me to find the degree measure of each angle. So I'm going to call this angle A and this angle B. So I'm going to go ahead and find angle A first. Again, it's an eeny, meeny, miny, mo. It's up to you which angle you want to find first. So I'm going to use A as my reference angle. Now, in relationship to angle A, this 1 foot is what? The opposite or the adjacent or the hypotenuse? Adjacent. In relationship to angle A, this side of the triangle, the 3 feet side, is what? The adjacent, opposite, or hypotenuse? Hypotenuse. So which trig ratio comes to mind when I am given adjacent and hypotenuse? Cosine. So what I'm going to do is set up my cosine ratio. So the cosine, again, remember I'm solving for an angle. So the cosine of angle A is equal to 1/3. So you can use your trig ratios to help you not only solve for sides of a triangle, but you can use them to solve for angles. So now remember in the last unit, in Unit 5, we now know that we can solve for angles by using the inverse trig functions. So to find angle A, what I can do is I can take the inverse cosine of both sides of this triangle. And that'll leave me with the inverse cosine. Inverse cosine of 1/3 is equal to angle A. So then on my calculator, again, make sure you are in degree mode. Remember, your inverses are found by doing the second cosine of 1 divided by 3. So anytime you want to solve for an angle, that's where you use the second sine, second cosine, or second tangent. So angle A then is about equal to 70.529 degrees. So any questions on how I found angle A? Now, I know angle A. Don't I also know another angle within this triangle? I know one angle is what? 90. So how could I solve for angle B? I can solve for angle B by taking it under 180 degrees and subtracting from that 90 degrees and the sum of 90 degrees and 70.529 degrees. So once you know 2 of the 3 angles, you can use that triangle sum theorem from geometry. So I put angle B to be approximately 19.471 degrees. Okay? So any questions on how you can use your trig ratios to help you solve for an angle? So like I said, you could use those trig ratios to solve for sides as well as angles in the triangle. All right, let's look at another one. So a right triangle has a hypotenuse of length 10 centimeters. If one angle is 40 degrees, find the length of each angle. So again, I'm going to set up my right triangle. They're telling me my hypotenuse is 10 centimeters. Again, all I know is that one of my angles is 40 degrees. They want me to find the length of each leg. So I'm going to label this leg as A, this one as B. Again, it doesn't matter which side of the triangle you want to solve for first. Again, we've got this reference angle of 40 degrees that I'm going to have to use. So let's talk about finding side A first. In relationship to angle 40 degrees, What is side A? Is that the opposite, adjacent, or hypotenuse? Adjacent. And I know what side of the triangle, the 10 centimeters, is the what? Hypotenuse. So which trig ratio comes to mind when we're dealing with adjacent and hypotenuse? Cosine. So I'm going to set up the cosine ratio. So cosine of 40 degrees is equal to A over 10. How do I solve for A here? What am I going to do to both sides? Multiply by 10. So then side A is going to be equal to 10 times the cosine of 40 degrees. So I type that in my calculator, 10 times the cosine of 40 degrees. I get 7.660. So there's one side of my triangle. Okay. So any questions on how I found A? Now I have to find B. So in relationship to my reference angle here, side B is what? Opposite, adjacent, or hypotenuse? Opposite, and I'm given the hypotenuse. So what trig function comes to mind when we have opposite and hypotenuse? Sine. So I'm going to set up the sine of 40 degrees is equal to B over 10. So to solve for B, what am I going to do? Multiply both sides by what? 10. So 10 times the sine of 40 degrees. So it was 6.428 centimeters. Like I said, always set up a diagram if it's not given to you. Okay? So any questions on how you can use the trig ratios to solve for angles or solve for sides of the triangle? All right, let's take a look at another one. So a ship is offshore from a vertical cliff known to be 100 feet in height. It takes a sighting of the top of the cliff. If the angle of elevation is found to be 25 degrees, how far offshore is the ship? So here's my vertical cliff. So when they say it's vertical, what can I assume? This cliff is what? To the ground. It's going to be what? Perpendicular. Here's my ship. Yes, I'm not an artist. So they're telling me that this cliff is 100 feet in height. So any questions on how I've started the picture so far? Now they're telling me that the ship is taking a sighting to the top of the cliff. So here's my ship. There's the top of the cliff. And they're telling me that the angle of elevation, now remember the angle of elevation is the angle that's above the horizontal. So this angle of elevation right here is going to be 25 degrees. Questions so far on the diagram? Now the question's asking me is how far offshore is the ship? So which side of the triangle do they want me to find, the hypotenuse or the horizontal side? Horizontal side, so I'm going to call that side X. So now in relationship to the reference angle, the angle of elevation that they gave me, which side of the triangle am I trying to find? Hypotenuse, adjacent, or opposite? Adjacent. And they're giving me the what? Opposite. So what trig ratio comes to mind when we've got adjacent and opposites? Tangent. So I'm going to set up my tangent ratio. So I'm going to take the tangent of my reference angle, which is 25 degrees, is equal to the opposite side, which I know is 100, over the side I want to find, which is X. So any questions on how I set up that trig ratio? Now, how am I going to start solving for X? It's going to be a two-step process. What's going to be my first step? What's going to be the first step? I'm going to have to do what? Multiply by X. So X times the tangent of 25 degrees is equal to 100. Then what? Divide by tangent of 25. So sometimes, ladies and gentlemen, after you get done setting up your trig ratios, it's a two-step process if that variable's in the denominator, like it was in this case. So I'll take 100 divided by the tangent of 25. So that's going to give me, the ship is about 214.451, include your units, which is feet. So any questions on solving that one? Okay. Let's take a look at number 9. You have a guy wire that's 80 feet long attached to the top of a radio transmission tower, making 25 degrees with the ground. So here's my tower. That tower better be perpendicular to the ground. So this wire is attached to the ground to the top of the tower. So here's my wire. Questions so far on the picture? They're telling me that the wire is 80 feet long. So I'll label that side of my triangle 80 feet. And they're telling me that this wire is making an angle of 25 degrees with the ground, which is also my angle of elevation. They want to know how high is the tower. So am I trying to find the vertical side or horizontal side of this triangle? Vertical. So I'll call that side X. So any questions on how I've labeled the picture? So in reference to the angle that I know, this 25 degrees, the 80 feet is what side of the triangle? That is my what? Hypotenuse. What side am I trying to find? The opposite or adjacent? Opposite. So what trig ratio comes to mind when we're dealing with opposite and hypotenuse? Sine. So I'm going to find the sine of 25 degrees, which is equal to x over 80. Any questions on how I set up that trig ratio? Now what am I going to do to both sides of this equation? I'm going to multiply both sides by what? 80. So 80 times the sine of 25 degrees is equal to x. So I can type that in my calculator. 80 times the sine of 25. So about 33.809, and this is in feet. So these are the right triangle trig application problems that we'll be solving in this particular section. Again, key is, guys, the picture's not given. Draw your diagrams and label it so you know what sides of the triangle you're dealing with. All right, so any questions on these problems so far? All right, let's jump. We're going to come back to the problems on page 3. Let's jump to page 4. So sometimes, like I said, guys, instead of you having to draw the picture, they'll actually have the picture set up for you. So again, we'll come back to page 3. Go ahead and turn to page 4. So the flagpole casts a 60-foot shadow. Well, first of all, shadows are always on the ground, aren't they? So again, we're going to label this side of my triangle as 60 feet. The flagpole better be perpendicular to the ground. So the angle of elevation to the sun is 35 degrees. So in my triangle, where is my angle of elevation going to be? The angle of elevation is always between the horizontal and above. So this has got to be your angle of elevation at 35 degrees. They want me to find the height of the flagpole, so they want me to find x. So any questions on how I've labeled the picture? What trig ratio are we going to use to set this up? Tangent, because again, we want to find the opposite and you're given the adjacent. So you guys go ahead and answer this for me. Go ahead and find how high this flagpole is. So did everybody come up with this flagpole to be about 42.012 feet? Okay? So any questions? Again, remember, guys, typically, just so you know, when we're dealing with angle of elevation versus angle of depression, angle of elevation is typically always the line of sight between the ground when you're looking up. We're talking about angle of depression. That's typically when you're in the air, like from an airplane, for example, and you're in the airplane and you're looking down. Now, just beware when you're dealing with angle of depression problems. The angle of depression, if you're in the sky looking down, that's on the outside of the triangle. But if you go back to your geometry, you can always take any angle of elevation problem, any angle of depression problem, and rewrite it as an angle of elevation. Goes back to your study of parallel lines back from geometry. Because remember, the horizontal on the ground is parallel to the horizontal in the air, that airplane that's flying. We don't, unless the airplane's coming in for a landing. What's the relationship when you have two parallel lines cut by a transversal? These are alternate interior angles. These are what? Congruent. So you can always take an angle of depression problem and rewrite it as an angle of elevation. They're congruent. Okay? So let's take a look at the next example. So you have a wire needs to reach from the top of a building to a point on the ground. The building is 10 meters tall, which they've labeled for you, and the angle of depression from the top of the building to the point on the ground is 22 degrees. How long should the wire be? So like I said, this is your angle of depression right in here. So like I just mentioned, what you can do is you can take your angle of depression problem, rewrite it as an angle of the elevation problem, so that's also going to have to be 22 degrees. Okay? So any questions on why we have 22 degrees written here and 22 degrees written here? So now, how long should the wire be? So given 22 degrees is my reference angle, what trig ratio is going to come to mind? Sine. So you guys go ahead now and find out how long this wire should be. So hopefully, guys, this is the way your trig ratio got set up. Again, sine of 22 degrees is equal to the opposite over the hypotenuse, where the hypotenuse is what you're solving for in this problem. Again, you've got to multiply both sides by x first, so that gives you x times the sine of 22 degrees is equal to 10. And then you have to divide both sides by sine of 22. So we end up at 26.695 meters. So any questions on that angle of elevation problem, an angle of depression? Like I said, you can take every angle of depression and rewrite as an angle of elevation. Here is another example. We've got a ladder that is positioned against the wall, and it forms an angle of 75 degrees with the ground. So here's my ground. Here's my wall. That wall better be perpendicular to the ground. So when I take a ladder and I'm going to lean it against the wall, the ladder turns out to be the hypotenuse of this triangle. So any questions on what the picture looks like so far? And again, they're telling me that this 24-foot ladder, so again, I know the hypotenuse of this particular triangle is 24 feet. They're telling me that the angle is forming 75 degrees with the ground. So for part A, they want me to find how high up the wall does the ladder reach. So do they want me for part A to find the horizontal side of this triangle or the vertical side? Vertical. So I'm going to call this side A. So in relationship to 75 degrees, which trig ratio am I going to use? I'm going to use which trig ratio? Sine. So I need to set up the sine of 75 degrees is equal to A over 24. So multiply both sides by 24. So 24 times the sine of 75 degrees is equal to A. That gives me 23.182, and again, this is in feet. So any questions on how I answered part A? So I looked at part B. How far is the base of the ladder from the wall? Well, there's only one side of the triangle left to find, so that's the horizontal side, correct? So I'll call that side B. So go ahead and then calculate how far away the base of this ladder is from the wall. So ladies and gentlemen, you should end up with about 6.212 feet. So any questions on working on those angle of elevation, angle of depression to solve those right triangle problems? All right, go back to page 3. Let's take a look at these other two problems. So these last two problems, guys, will require a few more steps in order to answer the questions. So I wanted to kind of do the basic ones first. That's why I kind of skipped over them. Now let's go back to ones that are going to involve a little bit more work. So to measure the height of the building, two sightings are taken at a distance 50 feet apart. So first of all, let me draw my building. So I know my building better be perpendicular to the ground. So two sightings are taken at a distance 50 feet apart. The first angle of elevation is 40 degrees. So again, I have a person on the ground right here, looking to the top of the building. That first angle of elevation is 40 degrees. The second is 32 degrees. So here's my first sighting right here. Here's my second sighting right here. And they're telling me that the distance between these two people is 50 feet. We want to know what is the height of the building. So ultimately, I want to know the height of the building, so I'm going to call that h. So I've got a problem. I've got two triangles, but I do not know the length of either side of these right triangles. All I know is the distance between these two people is 50 feet. This is not a right triangle. So what I'm going to have to do then is I'm going to call this first side of my right triangle x. So everybody agrees with me, I've got two right triangles in this diagram. I've got the smaller right triangle right here. So right now I've labeled this side as h and this side as x. I've got the larger right triangle if I look at the height of the building to the second sighting all the way out here to this whole side. What's the length of this whole side of the triangle going to be? X plus 50. So what I'm going to have to do is set up an algebraic equation to help me start solving for x here. So first of all, let's look at my first right triangle. In relationship to 40 degrees, I'm trying to solve for the height of the building. And again, this other side of the triangle I've labeled as x. So in relationship to 40 degrees, I've got the opposite and what else sides? I've got the adjacent. So I'm going to go ahead and set up my tangent ratio. So the tangent of 40 degrees is going to be equal to h over x. Remember, what am I ultimately trying to solve for? I'm trying to solve for what? Height. So I'm going to go ahead and solve for h. So h is equal to x times the tangent of 40 degrees. That's all I can do with that smaller right triangle. So any questions on what I've done? Now let's do the same thing, but let's look at the larger right triangle. Again, with this reference of 32 degrees. Again, I'm trying to solve for the opposite side, which is the height of the building. The adjacent side, the length of this whole side is x plus 50. So I'm going to set up another tangent ratio. So the tangent of 32 degrees is equal to h over x plus 50. Not 50 degrees, just 50. Again, ultimately, what am I trying to solve for here? I'm trying to solve for what? H. So I know that h is going to be equal to x plus 50 times the tangent of 32 degrees. So any questions, guys, on how I've set up the tangent ratios and then solve for h? Okay. Would you agree with me that the height of the building has to be equal to itself? Would you agree with that statement? So I know that the height is equal to x times tangent of 40. I know that the height is equal to x plus 50 times tangent of 32. So what do you think I can do with those two expressions? I can do what? Set them what? Equal. So I know that x tangent of 40 degrees is going to be equal to x plus 50 times the tangent of 32 degrees. Because if I can find x at this point, if I can solve for x, then I'll be able to answer the question and be able to solve for the height of this particular building. Would you agree with that? Because once I find x, I can plug it into eeny, meeny, miny, mo, one of those particular expressions, and answer the question. Any thoughts on what I could do at this point? Any thoughts on what I could do? What could I do? Well, x, I'm trying to solve for x. Right now, x is trapped inside the parentheses. I could distribute tangent of 32 or make life easier on myself. What could I do? Just simply divide by tangent of 32. So I have x times the tangent of 40 over the tangent of 32 degrees is equal to x plus 50. Remember, I'm trying to solve for x. Right now I've got an x on the left and an x on the right. So what I'm going to do is I'm going to subtract x on both sides of the equation. So x times the tangent of 40 degrees over the tangent of 32 degrees minus x is equal to 50. Remember, this tangent of 40 divided by tangent of 32, it's just a number. It's just a number. It's a decimal number. It's not a pretty number, but it's just a number. These are like terms that I can subtract. So on my calculator, I can just find the tangent of 40 divided by the tangent of 32. So that gives me 1.3428. So 1.3428 times x minus x is equal to 50. I'm sorry? Mm-hmm. These are like terms. Remember, the coefficient of this x is a 1. So when I subtract 1.3428 minus 1, that's going to give me 0.3428 times x. So any questions on where I got the 0.3428 from? So now what's the last step to solve for x? What am I going to have to do to both sides? Divide by 0.3428. Then x is equal to about 145.858. Okay? Does that answer the question? Look at what x is representing in the picture. X is representing this side, this horizontal side of this triangle, the smaller triangle, and then if I take that x value that I solved for and add 50, that's the side of this triangle on the horizontal side. But what question am I trying to answer? I want to know what? The height. So what do I have to do with this x value? I have to take this x value, plug it back into eeny, meeny, miny, no. It doesn't matter which one I plug it back into. So I'm just going to plug it into the first expression. So h is going to be equal to 145.858 times the tangent of 40 degrees. And I'm just going to type in times tangent of 40. So the height of the building is going to be 122.389. And that is feet. So like I said, sometimes you may have to solve for one piece of the triangle and then use that to calculate what the actual answer is going to be. All right, any questions on how I came up with 122.389 feet? All right, last problem. Glad we're not in Chicago, at least. Yeah, what's it going to be, like minus what? 50 or something in Chicago or something like that? It's going to be something crazy like that? So we've got the Board of Trade building in Chicago. So again, I've got a building. That building better be perpendicular with the ground. And adorning the top of this building is the statue of Ceres. So here's my statue. So here's my statue. There's my building. From street level, two observations are taken 400 feet from the center of the building. So again, the angle of elevation to the base of the statue is found to be 45 degrees. So again, from the sighting on the ground to the bottom of the statue, they're telling me that the angle of elevation is 45 degrees. And again, the sighting is 400 feet from the building. Then they're telling me that the angle of elevation to the top of the statue is 47.2 degrees. So we want to know, what is the height of the statue? So again, does everybody agree with me? I have two right triangles. I've got two right triangles. I've got one with the angle of elevation of 45 degrees. I've got another one with an angle of elevation of 47.2 degrees. So again, don't I have enough information, looking at the smaller right triangle, don't I have enough information to calculate how high this building is? Because I know that this angle is 45 degrees and I know one side of the triangle is 400. So does everybody agree with me? I can calculate this side of the triangle. Does everybody agree with me? If I look at my larger right triangle, I can calculate the distance from the ground to the top of the statue, which would be this whole side of the triangle, using the angle of elevation of 47.2. Does everybody agree with that? So if I know the height of the top of the statue to the ground, and I know the height of the building, what could I do with those values to help me calculate how tall the statue is? I could simply do what? Subtract them. So what I'm going to do is I'm going to call this side of my triangle y, from the ground to the top of the building, and the height of the building x. So then to calculate the height of the statue, which is what the question wants, I'm going to take y and subtract it from x. So again, it doesn't matter which one I find first, whether I find y or whether I find x. So let me go ahead and work on finding x first. So again, I'm looking at that smaller right triangle. I've got an angle of 45 degrees. I know that it's 400 feet from the base of the building. And in relationship to 45 degrees, which side of the triangle am I trying to calculate? The opposite, hypotenuse, or adjacent? Opposite. And I know which side of the triangle? Adjacent. So which trig ratio am I going to have to use? Tangent. So I'm going to take the tangent of 45 degrees, which is equal to x over 400. And if you're really good at your unit circle by now, you wouldn't even need to type the tangent of 45 degrees in the calculator, because what is the tangent of 45? 1. So what's x going to be equal to? 400. So now let's talk about the second right triangle. Again, finding the distance from the ground to the top of the statue. So again, I've got this side is y, which in relationship to 47.2 degrees is the opposite. I know the adjacent. Again, what trig ratio am I going to use? I'm going to use the tangent. So the tangent of 47.2 degrees is equal to y over 400. So again, I can take 400, multiply it by the tangent of 47.2 degrees. Obviously, we need to use a calculator for that one. So that's 431.961. So I know the height of the building is 400. I know that the distance from the ground to the top of the statue is 431.961. So now to answer the question, to find the height of that statue, I'm going to have to take that y minus x value. So the 431.961 minus 400. So the height of the statue is going to be 31.961. Is it in feet? Feet, yes. Okay. So any questions on the right triangle stuff? Okay. All right, guys. So let's talk about Thursday, or what could possibly happen on Thursday.